Hello guys, this is Code and Code and this is 15th lecture of this graph theory series part 1. In this lecture we are going to study Kahn's algorithm, which is there for topological sorting. The running time of Kahn's algorithm is V plus E, which is same as DFS or BFS. So the Kahn algorithm is simple, and at each iteration what we do for topological sorting, we choose a node which is having 0 in degree. So what is in degree? For each node, number of edges which are towards it are called in degree of that node. So for example, for node 1 there is one edge which is towards node 2, so the in degree of node 2 is 1. Similarly, for node 5 in degree is 2, for node 7 in degree is 2, for node 4 in degree is 1, because there is only one edge towards 4. So in degree are the number of edges towards a node, and in degree also tell you the dependencies. So in degree of 5 is 2, which means 5 have 2 different dependencies. So what Kahn's algorithm says, that each step will choose a node which is having in degree 0, which means all of its dependencies have been either traversed already or it have no dependency at all. So currently we see there are 3 nodes, 1, 3 and 6, which are having in degree 0, which means they do not have any dependency. So one more thing, topological sorting is not actually unique. For the same graph you can have different topological sorting which is valid, and for the same graph I can have different topological sorting which again is valid. So it is not like there is unique topological sorting for a given graph, but there are many valid topological sorting for a given graph. There may exist. So now let's continue with Kahn's algorithm. So let's choose one of the nodes which are 1, 3 or 6, because in degree of each of these nodes is 0. So let's say we chose node 1. So what we have to do, for each edge that goes out from node 1, we will remove all of these edges. So all of the edges are removed alongside the node 1, and then we will add node 1 into the topological sorting. Now we see there are 3 nodes again, 2, 3 and 6, so they're in degree 0. So we can choose any of the nodes from these 3. So we'll choose, say, 6. So we will remove 6 and all of the corresponding edges, and after that we'll add 6 into the topological sorting. After that we'll choose either 3 or 2, so we chose 3. We will add 3 into the topological sorting and remove 3 along with its edges. After that we choose either 2 or 4, suppose we chose 2. We will remove all of the edges of 2 and then add 2 into the topological sorting. After that there is only one node which is having 0 in degree, so we will choose node 4, and after that we'll remove all of edges of node 4. Also we'll add node 4 into the topological sorting. After that we are having 2 nodes within degree 0. We can choose any of them. We chose 8. We'll add 8 into the topological sorting. Now we only have one option, which is node 5, so we choose node 5, remove all of the corresponding edges alongside node 5, and added 5 into the topological sorting. After that you will choose 9 or 7, and then this is a valid topological sorting for this given graph. So what we do in Kahn's algorithm, at each step we choose a node which is having in degree 0, then remove all of the edges from it alongside that node, and we also add that node into the topological sorting array. So if I show you the implementation is just as easy. This should be good, this should be visible to you. So now what we are having 3 different arrays. First array is vector of this is vector for result. Okay, this will store this topological sorting array. So this is result, this is adjacency list representation of graph. If you are following this series from beginning, you already know about this. And this is an array to keep the in degree of each node. In the main function, we are having n, m, x and y. We are reading n and m, which are number of nodes and number of edges respectively. After that, we are reading m edges in the form of xy, indicating there is an edge from x towards y. This is not undirected but directed edge. So this is from x to y. So in the adjacency list of x, we will add y. And since the edge is towards y, so in degree of y will be incremented by 1. After that, we will call Kahn's algorithm or Kahn's function. So in the Kahn's function, we will create a queue to store all of the nodes which are having degree 0. So you see, we traverse the whole nodes, the whole vertices set one by one, and if the ith node is having in degree 0, we'll insert it into the queue. This will serve as a starting point for topological sorting. So the queue contains the nodes which are having in degree 0. Okay, after that we'll start. So this is similarly like BFS. So while queue is not empty, that means while there exists at least one node in the queue, we'll take out that node that will serve as current node, and we also add this node into the result. So this is like finding a node with 0 degree and adding it into the topological sort array. So we added it into the result, and we also removed this node from the queue. After that, we'll traverse each of the adjacency list of current node. For each node in the adjacency list of current node, what we will do, we'll decrease their in degree by 1. This is basically the edge removal process. So you take all of the node in the adjacency list of current node. That means there is an edge from current node towards them. So what we will do, we will remove their we will decrease their in degree by 1. So if after removing this edge, or after decreasing in degree of current this node, it may happen that in degree of this node can become 0. If that happens, then this node also will be added into the queue, because the in degree of this node is 0. So we will add this node into queue. After that, when queue is not empty, remember we are calling Kahn's algorithm assuming that valid topological sort exists. That is, the graph is DAG, that is directed acyclic graph. The graph doesn't contain cycle. We will handle the case when we have cycles in the graph, but in the I'll show you in the next lecture. So in this lecture, we are assuming that the graph is DAG and it doesn't contain any cycles. So the topological sort exists. That means when this while loop ends, the result contains a valid topological sorting. After that, we are simply printing all of the nodes in the result from the result array. So if I show you with an example, yeah. So for this graph, this is the example. There are 9 nodes and 10 edges, and these are the edges. So if you run Kahn's algorithm, this is what you get, which is a valid topological sorting. So this was all for this lecture. I hope you have got something from it. If you have any doubt or query, of course you can ask me, and don't ask in the comment section. Try to ask the question on the discuss.codechef.com link I'll be posting in the description of the video. So this was all for this lecture. Thank you guys for watching. Until the next video drops, keep coding. Thank you.